Welcome to the ET302 how-to video for capacitors and inductors filters lab. Okay, I built the test circuit in Multisim, and I will give you a copy on Canvas. And the first thing it says, what we have is this is the old school way to measure the cutoff frequency. Cutoff frequency is the way that the filters are rated, and the cutoff frequency equals 3 dB down or loss. And so it is 0.707 times the input voltage. It shows where the cutoff frequency is. And I'll show you a Bode plot here in a bit, and which shows the characteristics of this filter. And what we're doing here is we're setting this function generator up to a very high frequency. Since capacitors are high pass filters, they pass high frequencies and block lower frequencies. This one is set up for 5 volts peak. And what we're going to do is we're going to drop down the frequency until we hit the 0.707. So let's go ahead and get this turned on. Okay, and let's set this at 5. I will leave it at 2. Let's turn it on. Okay, and let's go ahead and get it set for 5, or at least show where it's 5. Okay, so we have 10 volts peak to peak on our input and output. Okay. Okay, let's go ahead and go to measure. 10 volts, 10 volts. Okay, I've already done the calculation and tried this already, because right now we need to start dropping the frequency until we get to 70%. So let's turn off our yellow. Yeah, we can leave it on. And go back to measure, and what I'm going to do is, since this is in kilohertz, I'm going to go ahead and start at let's start at 30. Okay, and since I've changed the frequency, I have to change the time on our scope. There we go. So right now we're down to 8.82, and what I want to do is continue to drop the frequency until we get to 0.707 times 10 will be basically a little over 7. And there's 7.08. Perfect. And let me go ahead and do a single, and let's go ahead and see if I could sometimes the display doesn't show, so I'm going to make a big picture of it. Okay, so what we have here is our 0.707 input signals 10 volts, and we're at 70%, or the 3 dB. So this filter would be rated at 16 kilohertz. Alright, let's use some of the tools that we have available to us. And we have instruments that actually do this too. What we're going to do is use a Bode plotter. The Bode plotter is what will make our characteristic curves for our filters. And we're going to have an input signal, and we're going to have an output signal, and of course we always have our ground. Okay, let's start our simulation and open our Bode plotter and see if we could get a good Bode plot and figure out what our critical frequency is, our cutoff frequency. Alright, so we're going to make this 100 kilohertz, and this one we're probably going to make it 1 kilohertz. And we go 5 and maybe -5. And let's turn that circuit on and off and see if we get some. There we go. Okay, so let's make this look like a Bode plot. And we'll make that 3 dB. Move it up a little bit. There we go. Yeah, there we go. And 100 kilohertz. Good. So here's a characteristic shape of a Bode plot. And this would be 100%. So let's go ahead and move our cursor and find the 3 dB point, and we can see that right here. And once we're at 3, right there, close enough, and we're right at almost 16 kilohertz. So both of these ways work. Okay, so let's modify our circuit with an inductor, and we're going to make it a low pass filter. Inductors work as low pass. They're going to block high frequencies and pass low frequencies. So let's go and do a replace. And we're going to go to basic and inductor. And we're going to go to 2.7 millihenries. Okay, let's see if we could dial this thing in. Good, and you can see this is a low pass because this is at the high and it gets blocked over here. So let's see where our 3 dB point is there. And right there. So we're at 59.278 kilohertz, almost 60 kilohertz low pass filter.